Alright, I'm going to show that this linear space P5 is isomorphic to M 2x3s. Which means, what do I have here? P5 is equal to the set of all polynomials of degree 5 or less. This dx squared, this ex, this f, such that a, b, c, d, e, f belong to real numbers. 2x3 is equal to all the sets of t, u, v, w, y, x, 2 rows, 3 columns, such that t, u, v, w, y, x belongs to real numbers. Alright, so I need to define a map between these two that will be a linear map, and it also has to be an isomorphism. Now let me remind you what an isomorphism is once more. I have to find an invertible linear transformation. And what I'm actually going to do is I'm going to show that that something is one-to-one and onto. So let's do that. I'm going to define t from my set of all fifth degree and less polynomials to m2x3 by t of ax to the fifth plus bx to the fourth plus cx cubed plus dx squared plus ex plus f is going to be equal to a, b, c, d, e, f. As simple as that. We will show t is one-to-one and onto, and therefore invertible. For onto, let t, u, v, w, y, x belong to the 2x3 matrices. Then I'm going to wow you. I'm going to come up with an input such that the output is this. Here's the input. Cx to the fifth plus ux to the fourth plus vx cubed plus wx squared plus yx. Wait, how'd I get out? Tu, v, w. Why do I have y in the next? That's a little messed up. Also, let's not do x because that's my variable. How about z? And then z, wx plus z. So take all these real numbers here, just put them in the coefficients, and then there's that. So t is onto. How do I know it's onto? You tell me any matrix, I'll map it by this input. And then one-to-one. Let's see. How do I show something's one-to-one? I'm going to assume that suppose t of ax to the fifth plus bx to the fourth plus cx cubed plus dx squared plus ex plus f is equal to, oh boy, I'm going to turn to Greek letters here. Alpha x to the fifth plus beta x to the fourth plus gamma x cubed plus delta x squared plus epsilon x plus b. I'm not sure if that comes next, but something like that. Suppose that these two outputs are the same. I'm going to show that these two inputs with the regular letters and these two and this input with the Greek letters will be the same. Well, what does this output mean? It's a matrix. A, B, C, D, E, F is equal to alpha, beta, gamma, delta, epsilon, phi. The only way these two things can be equal is if A is equal to alpha, B is equal to beta, C is equal to gamma, D is equal to delta, E is equal to epsilon, and F is equal to phi. So ax to the fifth plus bx to the fourth plus cx cubed plus dx squared plus ex plus f is equal to alpha x to the fifth plus beta x to the fourth plus z plus b. So t is 1 to 1. If you think that you have two outputs, t of that thing and t of that thing, they're the same, well, actually the two inputs were the same. So you're looking at the exact same expression here. Since t is 1 to 1 and onto, t is invertible. So t is an isomorphism. And if t is an isomorphism, we say that the domain and codomain are isomorphic. So P5 and M2 by 3 are isomorphic. We're done.